So welcome everyone. Welcome to another virtual classroom session. I am Peter Arthur, and I do appreciate your taking time out of your day to be here with me today. And what we're going to do is today we're going to talk about what's called RTMoE protocol. So, excuse me, I'll be defining what that is and giving you an overview. We're also going to be talking about network design considerations, which is something that you wouldn't necessarily think of when it comes to drives and motors, which is what we do. But anymore, with the proliferation of Ethernet-enabled devices, the design of your network is a non-trivial matter, and I'm going to be discussing that here this morning. And then as an example, today we're going to end up with configuring easy mode, what's called an easy mode link. So that's what I have on the agenda for today. As before, we'll take a break midway through, and then we'll finish up. And if you do have questions, I think you should be able to unmute yourself using your WebEx control panel there. So just speak up. But if you are in a noisy environment, I'd appreciate it if you keep your microphone muted and use the chat feature instead. So to begin with, I'm going to discuss or define what RTMoE is. And what it is our proprietary high-speed peer-to-peer networking protocol. RTMoE stands for real-time motion over Ethernet. This protocol is based on IEEE 1588-2008 standard, which is a mouthful, but what that means is, and I've taken this directly from the IEEE website, its precision time protocol is a packet-based two-way communication protocol specifically designed to precisely synchronize distributed clocks to sub-microsecond resolution, typically on an Ethernet or IP-based network. So this communication protocol is designed specifically to synchronize clocks over Ethernet. And as a result, it was developed and originally used to synchronize the clocks of ATMs in the banking industry. So that's what the protocol that our RTMoE is based on. Historically, our drives, we've always been known for having the ability for peer-to-peer communication between drives in a network. And in some of our older equipment, specifically Unidrive SP, let's say, you had, whenever you had an application module, an SM application module, or even the base drive itself, you had the option of using either CT sync to communicate between drives on the network, or CT net. Both of those protocols were RS-485 based originally. RTMoE, on the other hand, is now our Ethernet version of that messaging protocol. So rather than RS-485, we now use Ethernet as the mechanism. So in order to use Ethernet, of course, you have to have an Ethernet enabled drive or an Ethernet application module to use this protocol. So this protocol, is available using our M700, M701, and M702 high-performance AC drives. You can also use it with the Digitex HD M750 and M754, which you may not have heard about. The M750 is the Ethernet-based Digitex drive, and as such, it's got a network switch right there. The M754 is our newest Digitax drive, and it looks the same. But if you've ever used a Digitax drive before, you know that in order to use any of our expansion modules or application modules, you had to have an adapter and then, of course, the module itself. The M754 drive, what it does that's different is our MCI control module, as it were, is built into the base drive itself. So rather than occupying one of the two expansion slots on a Digitax, now you have onboard MCI control, which is programmed with Machine Control Studio, and two free slots that you can use for other things like I/O or encoders or what have you. So that's the M754. The M751 is a serial-based drive. It looks like this, but it's serial RS485 here. Now that doesn't mean you can't use this protocol, because you can include the SI Ethernet module in one of the expansion slots. And that also, the SI Ethernet, which you see here, can also be used with our general purpose commander drives, and it performs the same functionality. So the RTMoE protocol is available on the Unidrive M700, a Digitax, and our SI Ethernet module that you see here. So what does that have to do with the drive? Well, our drives rely on a microcontroller clock to schedule common VFD tasks like updating the speed loop, the current loop, and handling communication. So as a result, and by our using this PTP protocol, whenever two or more drives are connected over Ethernet, their control loops can be synchronized to within nanoseconds of each other. And I'm going to be demonstrating this, but the deviation between clocks, or the speed error, as it were, is called jitter. So you're going to find that when I put Connect software up on the screen, that we are very, very tightly synchronized. The clocks are down in the single nanosecond range, as a matter of fact. So it works very well. Once the control loops are synchronized, and by the way, there's nothing you need to do to make that happen. Anytime you plug, for example, two M700s together on the same network or more, this process will automatically begin, the synchronization process. And once the control loops are synchronized, it becomes possible to perform high-speed cyclic drive-to-drive messaging with a maximum transmission of 250 microseconds. So this is much the same as using any other cyclic field bus like Profinet or even EtherCAT. Our design goal is eventually to at least equal, if not better, the performance of EtherCAT, which is Beckhoff's proprietary communication protocol. So again, the clocks and the drives are synchronized together, and the example I'm going to show you today is synchronizing the speed of one motor to another over Ethernet. And when you think about it, if the clocks are synchronized to each other on the network, therefore all of the control loops are also synchronized to each other. So it's kind of like a parallel system. If I issue a command to one drive and the clocks are all synchronized and they're all on the same network, well then it's possible that all of those drives will receive that same command within nanoseconds. So it's very powerful, and you'll find it works very well. So how this works is like this. And again, it comes back to the moment that you connect multiple drives on the same subnetwork, this process of RTMoE begins running. And it's a free-running test algorithm that's used to determine which drive in the network is performing the best in terms of message transmission. So the moment this drive here, this is the subscriber, let's say, and that's the producer, the moment those two are connected and identified, this drive, I'll say is the producer, will send a message here to this drive with a timestamp. So this drive gets that message, includes a timestamp of its own when it was received, then it sends another return message back to the host. The host, therefore, says, how long did that take? What was the latency between the time the message was sent and the time it was received? And whoever is performing the best, for example, it's not just this one might have taken longer to return the message than this one did. So what happens then is whoever is doing the best in terms of performance when it comes to sending and receiving messages is awarded the title of the Grand Master, which is my favorite term by far. I've always thought I should probably put that on my business card, but anyway, Grand Master is, and you'll see that even in Connect software, which I'll show you, who's awarded the title of Grand Master. So that's how the synchronization part works. It's purely based on time-based messages and who's doing the best in terms of sending and receiving networked messages. So there's 3 different types of messages available when you're using this protocol. They are cyclic, non-synchronized, cyclic, synchronized, and then just straight non-cyclic. Now the differentiator between cyclic message types, these two, is whether or not the messages are synchronized to the control loop or not. So when I say cyclic synchronized here, those messages are for mission critical data. So that is the highest performing type of message because that message is tied into the control loop in the drives once the clocks are synchronized. So you'd want to reserve these cyclic messages for, things like sending the speed of one drive to the other, like I'm going to demonstrate. That's an example of a mission critical message packet. And then non-cyclic messages also, it's kind of like using a message instruction in a traditional PLC. You have, rather than being periodic or cyclic, they are more of an explicit message. So we support that as well. And another thing I don't show here is what's called ECMP protocol. That's a subject for a different different training course. But today today and tomorrow we're gonna focus on these 3 message types. Now, before we actually get into the software and I start showing you an example of how this works, it's very, very important that before you do anything, you pay close attention to how your network is designed. You kind of have to put on your IT guy hat here when you are considering using this protocol, and you'll see what I mean here in a moment. Now, if you only have 2 drives in the network or something to that, 2, 3, 4 drives, what I'm about to show you becomes less important, but still, it's still good practice to follow along here. But The network has to be designed to avoid what's called a network bottleneck. And then a bottleneck is an area of the network where there's more network traffic than the drive can process. Now, an example that's happened in the field with me is when I'm doing this in person, I'm demonstrating this in person in a class, it's happened where people have connected our drive up to their corporate network. That when you start a project with Connect, if your computer's network adapter is on your company network and you use our Connect software to configure the IP address for the drive, well, it's going to put it onto your company network. Now, when that happens, you can expect a call from the IT guy because they're going to notice immediately a huge increase in network traffic. And that results from this arbitration process to see who's doing the best when it comes to communication. So you do have to be careful. And in extreme cases, this bottlenecking can cause lost messages and drive trips. So to avoid that, the UniDrive 700 factory fit module, which you may or may not see in our literature or brochures, it's abbreviated FFM. Sometimes it's factory fit Ethernet module. That can be used to perform packet filtering and other tasks that are commonly associated with a managed Ethernet switch. So this is I'm pointing out the M700 here, but in fact, the Digitax is the same. It has the capability to perform some of the features of a managed switch. Now, these features that I'm going to show you are of particular importance when drives are networked to one another, and especially when there's a PLC that's part of the same network. That's when you must implement these features that I'm going to show you here. So in terms of network design, our factory fit modules, not just the UniDrive M700, our factory fit modules support a star topology, which is kind of the classic Ethernet topology where every device has a path to the switch. So 4 drives, 4 patch cables, 4 ports on your network switch. Now, a star is not recommended when you're using a PLC in the network and the drives are communicating with RTMoE. And the reason for that is that, it's just a huge increase in network traffic. So there are ways that I'm going to show you to alleviate that. So there's a star and then there's a line. Now a line is what we do recommend. What you're going to see in the examples that come up is if you have a multi-axis machine, and we're talking 10, 12, 20 drives or more, ideally what you're going to want to do is you're going to want to segregate those drives or group drives that have similar purpose into a line. All right. Now the trade-off or the thing you need to watch for is that you cannot have any more than 10 drives or SI Ethernet modules in a line. All right, so the line is limited to 10 drives whose switches are connected to one another. Now, as of today, we don't support ring topology, but ring topology is currently in beta testing. I just saw an announcement about this earlier this week, and that will be available soon. Now, I don't have an example of a ring topology, but with a ring topology, each device has 2 connections to multiple switches, or 2 connections to 2 switches, so there's redundancy there in your network. So star and line are what we're going to focus on today. So here, excuse me, here's an example of a star topology. Very classic. I've got a PLC, I've got a switch, then I've got two drives. All three devices have a direct path back to the switch. Now, the choice of switches that you use is not arbitrary either. The switch that you use should support the EEE 1588 PTP protocol as well. Obviously, we're going to be passing messages through the switch using that protocol, so the switch you choose should support that technology. And I think, at least lately, the Moxa and some of your better quality switches do support 1588 V2. So, don't go down to Walmart and buy a switch and say, okay, that's going to work. You're going to need a little better switch than that. So here's a line. And again, you can see right off the bat, okay, what's an advantage? Well, the advantage there is I've got, 1, 2, 3, 4, 5, 6, 7 drives connected to the switch with one connection, as opposed to taking up 7 of those 8 ports if I were using a star. So again, limit the number of drives to no more than 10 in a line. This is the best solution, and this is called a tree. A tree encompasses both a star and a line, and it uses multiple switches. So in this example, I have segregated these drives into a line topology because they are related. In other words, this one might be the master for speed, and these two are the followers. And this whole group of drives, the whole group of 5 drives, that could be, I don't know, the in-feed section on the machine. All of them, line, star, in the case of those two, are connected to a switch, and the switches are, and then there's another switch with another section of the machine doing the same thing. There is a connection between all of them through the switches because the switches can communicate with one another as well. So the takeaway from here is that for best results, you should group drives that are performing or need to relate to one another into a line such as this. So that whole network then becomes what's called a tree. So what's a bottleneck? What's too much network traffic? I give a lot of credit to our engineering staff in the UK for coming up with this. I mean, it's one thing to say, well, yeah, there's too much network traffic. It's another thing to actually define what that is. So that's what you see here. And by the way, our factory fit Ethernet modules on the M700 or the Digitax can run Modbus TCP Ethernet IP. Now with version 2, newer drives within the last year or 2, I guess now, also support Profinet and RTMoE. So in theory, I could have all 4 protocols running simultaneously. Is that a good idea? Yeah, maybe not. But the fact is that you could do that. So this is just an example of Modbus TCP, Ethernet IP, and RTMoE, all 3 active protocols on the same switch. So here's the number of parameters, you can see this. 10 read parameters over Modbus, right, at a rate of 100 milliseconds. So that becomes 100 parameter accesses per second. So that's 10 messages per second, right? So you have parameter accesses per second and message rates, and here are the maximums. I can have 6,000 parameter accesses per second, and I can have 8,000 messages per second with either the M700 or the Digitex HD. So you simply lay out your network communications scheme like this, add them up. If they don't exceed these values, you're good to go. So that's good information there. And I was always under the impression that, you know, gosh, who would want to add all that stuff? It's kind of funny anymore that people are really into data acquisition now, and they want to know everything about what the drive is doing, and for good reason. One of the big news items in industrial automation these days is predictive maintenance. You know, people want to know, hey, when is, you know, what are the IGBTs working in the drive? What's the temperature in the drive? Is it taking more current? So, you know, yeah, there's going to be a tendency for more and more network traffic over Ethernet. So this chart, and this isn't really even up to date, so it may be even better than that, but as a baseline, we'll go with those numbers. So what causes network delays? Well, there's a number of variables that can impact the performance of an Ethernet network, and that includes switches themselves. You know, Ethernet's switch network and messages are typically copied completely into a switch before being passed on. So a switch itself, whether it's an external switch or the built-in switch on our drives, could be causing network delays. The length of the message, the longer the message, the longer it will take to transmit and copy to a switch before forwarding. So message length can cause network delays. And finally, the length of the daisy chain. You know, how many switches in a row do you have? You know, we just defined that a switch itself will cause a delay. Well, if you've got a bunch of them in a line, you can expect some delays too. And those delays are called latency. All right? So again, you want to limit your daisy chain line technology or line topology to no more than 10 devices, 10 switches in a line to limit delays. So those are just some general Ethernet fundamentals that are important now that we have drives that support this protocol. So here's an example, you know, that we put together of how to specify and support synchronous cyclic data that offers accurate synchronization and guaranteed determinism. You can tell this is not a slide that I put together because there's the word whilst there. I don't find myself using that word very often. That's from my little English friends. So whilst maintaining compatibility with standard Ethernet traffic. Right? So if you need to have more than 10 drives in a line, you want to use a tree structure with another switch. And again, Ethernet switches should support the EEE 1588 v2 protocol. We do sell a switch that we have private labeled. I mean, we don't make switches, but SW100-5 is the model number of that switch. And of course, segregate the network using VLANs, virtual local area network, and gateways. And those are two functions that are offered as part of our factory fit Ethernet module on our drives. Assign one device to be the synchronization master. So when we're putting this in practice, you know, I mentioned earlier on about that arbitration process, you know, who's going to be the grandmaster, who's doing best, yada, yada. In practice, what you're going to want to do is assign one drive to be the grandmaster all the time. You know, that's just going to cut down on a lot of extraneous network traffic, and I'm going to show you how to do that here in a little bit. So here's an example of a large network. So in this case, I have 12 drives. And what I've done here is I have segregated those drives into 3 sections. This might be the wind-unwind section of the machine. This would be the roll former section. And here's the finishing section. So what I've done is each one of these sections has a drive that is designated as an Ethernet gateway. And a gateway is going to be used to filter packets coming into the gateway drive. Now there's a couple different options for gateway. There's general gateway, which will also include messages coming in over Ethernet IP, but there is strict gateway, which will limit the messages coming into the gateway to only those messages which are relevant to the drives that are part of this segment. So I've chosen gateway here for this drive, and this drive. The members now of this section, they have their ports set to be a normal switch. So gateway, switch, and that's kind of the way it flows for all of these guys. I'm also going to be setting up a VLAN for each one of these sections. VLAN 0, VLAN 1, and VLAN 2. So VLAN is actually going to put a label on each message, and that way it will be that will also help to increase throughput down the line that you see here. So the important thing is gateway. You have a gatekeeper in front of the other members, and then you also include virtual local area networks as well. Why do all that stuff? Well, it's going to improve network performance and avoid those bottlenecks I was telling you about earlier. So, how do you do this? Well, the settings for the factory fit Ethernet module are located in what's called slot 4 menus for the Unidrive M700. If you're familiar with the Unidrive M700, it has 3 expansion slots. So the Ethernet switch is referred to as slot 4. If it's a Digitax HD, that only provides 2 expansion slots. So the Ethernet switch is slot 3 on a Digitax HD. And to access these parameters, you use this structure where the slot number is X. So it's slot dot menu dot parameter. So down here, I have an example, a screen capture of the Unidrive M700 Ethernet dashboard. And I've dropped down the parameter listings. And here you'll see this is 402. What that means, it is slot 4 menu 2, slot 4 menu 9, so on and so forth. If this were a Digitax HD, you'd see the same thing, but it'd be 302, 309, 310, blah, blah, blah. So what needs to happen is we need to set up the parameters for our Ethernet using the menus found here. And notice also, that's the Ethernet dashboard. I'm going to show you in Connect when we get to that point. There's also in the parameter listing menu 24, which has some diagnostics for the Ethernet port, but the actual parameters are found here on the Ethernet dashboard in the parameter listings. So, the slides that follow have a chart that shows recommended settings for each gateway and each member drive, right? Now, it's assumed that you've already given each drive a unique IP address, and that you're also using quality cabling, shielded Ethernet cable. You know, you really need to pay attention to the quality of cable. Again, Walmart stuff isn't going to make it when it comes to doing a network like this. You need actual IT guy stuff, which is good cable, and not only good cable, but shielded Ethernet cable as well, particularly if you have long runs. And by long runs, the maximum segment length is 100 meters. So I can only have 100 meters from one device to another. If it needs to be longer than that, then you put a hub, not another switch, but you put a hub in to act as a repeater or an amplifier. The PLC is communicating using Ethernet IP. All right, so we have a PLC. And if no other protocols are in use, then disable them. So you can go in and disable Modbus in slot menu 15. You can also disable Profinet. If you're not using them, disable them. So I'll show you that here in a moment. So referring to our network, these are the gateway access settings. And I will just flip over to connect here now and show you that. Right, so here is my setup. I have two axes. I have a producer axis, and then I have a subscriber axis. So in my example here, I'm going to look at the settings for the producer axis first. So as you can see, I'm online with the producer axis, and it's a Digitax drive. And here's the Ethernet dashboard. And here are the parameter listings. And notice there's the grandmaster. Now, that's there on purpose, but that's what I was telling you about. It shows that this device is in fact the grandmaster. The status, the interface is active, and I'm 240 some frames per second, or 240 messages per second. So if you look back at that slide that I showed where we show the maximums, this is an easy way to configure or to determine what the data traffic is. Now, of course, you can use programs like Wireshark too, but I found that software, you kind of have to know something a little bit more about Ethernet than you might want to know in order to use Wireshark, but that's useful information. And then this stuff up here is what I'm going to be configuring right here. So I'll go in now to parameter listings, and there it is. It's a Digitax, so it's slot 3, menu 2. Now if I reflect back on the slide, the first thing, this is for an M700, so it shows slot 4, but you get the gist. So I'm not using Ethernet IP here in my example, so I don't care about this. But if you were using it, here's what you would do. So if I look at parameter 20 right there, it says none, right? So if I drop that down, I can choose, if I did have a PLC there, I would select Ethernet IP. Now what does that do? Well, by default, Modbus and Ethernet IP would be given a 5 millisecond time slice equally. But if I choose one to be the priority, then it gets a 2 millisecond time slice. So it is treated as a priority, as the name implies. Here today, I don't really care so much because I don't have a PLC there. So I'm going to say none. So we'll start there. Next is parameter 25. Here is where I turn on the gateway. So this drive is the gateway for my network, and my network consists of 2 drives today. So not that significant, but if I had if I had a large network, that would be very significant. Further, the next parameter is VLAN tagging. That's parameter 30. So it's a gateway, and I'm also enabling VLAN tagging. Now, this is important also, the VLAN ID. You can have up to 4 VLANs. Well, let me see here. Oh, no, sorry. You can only have 1. Sorry. So VLAN ID is 1. Right here. Right? So that's VLAN 1. Now, that's menu 2. Now let's look at menu 11. So there's menu 2. This is called RTMoE sync. So the thing here is this is the gateway drive now. So I am nominating that this drive is always going to be the grandmaster by setting this parameter, menu 11 parameter 1 to 1. Doing so means that the arbitration process that would emanate from this drive will never occur. This drive is going to be nominated to be the RTMoE grandmaster for the section. So let's look at that. Right there, preferred sync master. If that were 0, and you'll see that by default, if it were 0, that means that this guy would become part of the arbitration process, and it could be this guy, it could be any of the network drives. But by setting it to a value of 1, that means no, this is going to be the preferred sync master. And we can also have what's called a time domain. Again, it's clocks, it's time, it's synchronization. So there are multiple time domains that this drive could be a part of. Well, I'm going to say that this drive is going to use time domain 0. So that's what I have here. Master clock domain 0. So that's all I need to do in this particular menu 11. And in fact, that's all I need to do to set up the gateway drive in my network is set the settings in menu 2 and menu 11. You can see some other useful information in here too. It tells you, for example, that the jitter from the grandmaster, well, it is the grandmaster, so there's going to be no jitter. But you can see the PTP time shown here. And if I were to look at the other devices in the network, they would be pretty much spot on with that one because they're synchronized. So that's menu 11. So that's all I need to do for the producer drive in my case. And if I back up a little bit here and show you that picture again, that's these drives. So today, in my example, I only have, that's my network, 2 drives, but understand that what we just looked at would be the same for each one of these gateway drives in the machine. Okay, does anybody, let's see here. Does anybody have any questions at this point? Go ahead and unmute yourself. Ask away. If there are no questions, we'll take a 10-minute break here, and I will come back at 11. Recording again, and we'll resume. Does anybody have any questions before I start? We doing all right? Super good. Glad to hear it. All right, we left off. I was showing you the gateway drive settings. Now we'll go look at the subscriber or follower or whatever you want to label it as settings, or member, I guess, to follow along with my example. So I'm going to go right back into the same menus we just looked at. But then, there again, I'm using a Digitex today, so it's 302. All right, so there we go. Now I'm going to close this one. And then I'll go to my subscriber. I'm online with it. And then I'll go to Ethernet. Now, there's some things I want you to notice here. First and foremost, is this drive clock synchronized to the Grand Master? Yes, it is. That is oftentimes overlooked. People want, they say, oh, my messaging's not working. What's going on? Well, you want to look here to see if, in fact, this drive is part of the RTMoE network. Synchronized means yes, it is. And here is the deviation in terms of messaging between the Grandmaster and this subscriber drive. And as you can see, we're in the single nanosecond range in terms of messaging. That's to be expected. Yes, I'm here in an office environment with, not a lot of noise being generated or anything like that, but that's the kind of performance that you can expect when you're using this protocol. So let's look now at the menu 2 settings. So the thing that's important is down here, gateway mode. I'll go back to my slide here. Oops. There it is. Gateway mode, right? Well, I don't care about Ethernet IP again, so I'm going to skip over that. But if I go to parameter 25, I want to make sure that this one is set up as a switch. So I'll come down here. So that's default. You don't need to change anything. So this is a switch now. But I do want to make sure that I enable VLAN. If I don't do that, I won't be able to receive messages coming through the gateway that have a VLAN tag. So I have enabled VLAN, and the VLAN ID is 1 to match my gateway drive. So that has to be enabled, and that has to match what I'd set up for my producer drive up here. So in terms of menu 2, that's all we have. Now let's go look at menu 11. So I'll switch down here. Now the first thing we do is to make sure that this drive will never be the sync master or the grandmaster. And to do that, I've just disabled arbitration by setting that parameter to a value of 0. So that's very important. And as you'll recall, our gateway drive was on time domain number 0. So I want this drive to also be on that same time domain. So therefore, I have that parameter set to 0 as well. Now that's default, so I didn't have to change anything. I did have to change that. By default, everybody can be a sync master. So that's the only parameter I changed here in this menu. All right, so that's the member drive settings now. When you have made changes to slot 3 or slot 4, what you need to do is reset the protocol, right? So that's done in slot 4, menu 0, parameter 7. So let's go look at that. Or slot 3, in my case. Right, so to do that, what we're going to do is we're going to come over here now to the parameters. Menu 0 is going to be right there. So let me rephrase that so you are clear. What you're looking at here, that's menu 17. Well, it's menu 17 because it's slot 3. You know, if I had a encoder card in the expansion slot 1, that'd be menu 15 on my Digitax. If I had something else in slot 2, that'd be menu 16. But because the Ethernet slot or factory fit module is considered slot 3, menu 0 parameters are found in menu 17, which is a little confusing. But here's the reset I was referring to right there. So once you've made your changes, you're going to want to reset by clicking that on, and it will turn itself off after it's reset. So again, once you've made those changes, you reset the protocol, right? So that's actually menu 17. I should just say 1707 in my case, not slot 4. It's 1707. Save the parameters in the drive, right? You know, the usual, right there. And then as the last step, it's not a bad idea to come back here and do a reset. It's not so important when you made those changes I just did, but when we actually start setting up messages, I'll need to do that. So right now, both drives are synchronized. I've got the clocks are synchronized. I've got a gateway, and then I've got a single subscriber out here. So we're looking good at this point. Now, what I'm going to demonstrate today is what's called easy mode links. Right? What we're going to find out is there's two ways of using these links. Easy mode being, well, the easiest way. And then tomorrow, what I'm going to show is the advanced link editor that's part of Machine Control Studio. It's a graphical tool that's used when you're using MCI 210 modules for your network as opposed to the standard factory fit modules that I'm demonstrating today. So an RTMoE easy mode link consists of a contiguous group of drive parameters. So what I mean by contiguous is the parameters that you'd like to share amongst the network subscribers has to be arranged into a group of consecutive parameter numbers. So what I can't do is send, the feedback position, which is menu 302, the drive enable status, which is menu 629. The parameters that you want to use as part of one of these links have to be in a group of consecutive parameters. So you can do that by mapping parameters into menus 0, 18, 19, and 20 on a base drive. And when you're using an MCI module, you'll find that there are additional application menus 70 through 79. So let's have a look at that. Right, so I'll go back here. So menu 18, right? So what I can do here is I can map my parameters here as long as it's an integer data type, right? I could click there and map my parameter that I want to send. And contiguous means that I have to use a block of them all in a row, like so. So there's menu 18, 19, same kind of thing. Right? If I scroll down, there's bits, there's long integers. Those are your power down long integers, right? Menu 20, same kind of thing. Now, menu 0 is what a lot of people will do if they're sending, if you have a lot of traffic or a lot of data you want to share. And let me show you what menu 0 is all about. So menu 0, you can see menu, and maybe maybe you don't know this, but menu 0 is a collection of parameters that are taken from these other menus and assembled into menu 0. It's called the quick access menu, quick setup menu, I guess. So this menu 0 is configured using menu 22 that you see right there. So if I open menu 22 now let's remember the menu 0 parameter 1 says minimum reference clamp. And then let's go look at menu 22. So menu 22 parameter 1 is the setup parameter for menu 0 parameter 1. So minimum reference clamp comes from menu 1. Menu 1 parameter 7 is therefore an alias for menu 0 parameter, I had that backwards. Menu 0 parameter 1 is an alias for menu 1 parameter 7. Now if I go look at menu 0 parameter 10, I expect to see speed feedback. There it is. So you see the relationship between menu 0 and menu 22. You can customize this to your heart's content. If you don't want to see speed feedback, well, okay, make it 0. Right? Save. Reset. And now let's go look. See? 9:11. So you can customize menu 0 to include only those parameters that you want to see or that you want to provide access to. But when it comes to messaging, if I scroll down here, look at all this. I can literally wipe out as many of these parameters as I'm not using, and these become excellent candidates for my network messages, because the other thing about menu 0 that you don't know is all of the parameter values that are stored in menu 0 are automatically saved to flash memory. So on a power down, the values of any parameter in menu 0 are going to be retained on power up. So, literally you have 79 parameters that you could map to menu 0, and then that's what you'd use for your block of contiguous messages. Now, I don't have that elaborate of an example set up today, but just so you understand that that's very commonly done when you want to share a large amount of data from one drive to another. So there's two ways to create links. We're going to use easy mode, and then tomorrow I'll show you how to use the graphical link editor, advanced link editor in Machine Control Studio. So easy mode links are configured using the menus found in slot 4 for an M700 or slot 3 for Digitex HD, and specifically menu 10. Each drive can transmit up to 3 easy mode links and receive up to 3 easy mode links. Each one of those links can contain up to 10 parameters. So therefore, I have a maximum of 30 easy mode parameters out and 30 easy mode parameters in per drive. Hopefully that is clear. So here are the individual parameters in menu 10 that we're going to be configuring for each one of those 3 links. That's showing transmit link 1. So let's go look at what those parameters are now. First thing is the link profile, which is menu 10, parameter 10, for transmit link 1 anyway. Here's where you decide whether that's a standard message or a synchronized message. So back in the beginning of the presentation, I said there's 3 message types: cyclic synchronized, cyclic non-synchronized. So parameter 10 in menu 10 will make that determination. If it's not mission critical, well, make it a standard link. If it is mission critical, make it a sync link. Parameter 11 is the link number, right? So, generally, 0 means that the transmitted link is disabled, but you can choose any number for the link between 0 and 255. Parameter 12 is where we're going to determine the source parameter. This is a transmit link now, so it sets the number of the first parameter in the block of contiguous parameters being transmitted using this link. So 1811, menu 0, parameter 10, 2001, whatever you're going to be sharing with the members of your network, this is the first parameter in that block of parameters for link 1. Then we have a parameter count. So here's where the contiguous part comes in. The quantity of subsequent based on the source parameters to be included in this message packet. So you can have a minimum of 1, which is the parameter of source itself, or up to 10 total. So if I've chosen 1801 as my source, and I have 5 here, then my packet is going to include the current values of the parameters in 1801, 2, 3, 4, and 5. So those are the parameters required to set up a transmit link. Now, the transmit link transmission type. This is the method of message transmission for the link, and your options are broadcast, which, as the name implies, sends that packet to all subscribers on the network. Here is where you need to be very careful. This is where network design comes into play. Broadcast messaging, of course, is going to consume the most bandwidth, so you do have to be careful. If you only want to send the message to one member of the network, we'll use unicast then. And finally, multicast. Our Ethernet switch, our factory fit Ethernet, supports multicast groups. There are 10 groups available. So with multicast, you can send that packet to only the subscribers who are part of the same multicast group. And again, we have 10 groups available. So if you've chosen the unicast as the type of message delivery here, if you've chosen that for parameter 14, then you need to enter the IP address of the subscriber here in parameter 15. So in other words, where's that unicast message going to land? Who's going to get it? And then finally, we choose the message rate. So 0 is disabled to 100 milliseconds. Now you may recall earlier that I discussed cyclic message transmission in the microsecond range. That is not an option with factory fit modules. About the minimum you can go down to is 4 milliseconds, I would say. That's a safe message transmission rate. So again, if you want to get down in the microsecond range, which I'll show you tomorrow, we use Machine Control Studio and an MCI 210 to do that. Transmit parameters. Now, what about the receiver? What about the subscriber? Well, again, menu 10 parameter 40. Let me show you that. Right, so let's close all this hoopla. All right. So I'm going to go to my transmitter, which I've labeled producer, Ethernet, and let's look at menu 10. There it is. Right? So transmit link profile, link number. So here's my transmit 1, transmit 2, transmit 3. There's my links, my 3 transmit links. Now starting down here, there is my receive link. So what I'm going to do is now we'll look at the subscriber, Ethernet, menu 10, starting down here. So this is the guy that's going to receive the messages. So the first thing is the profile, and it has to match what the transmission link is doing. So if you're transmitting a synchronized link, you better be prepared to receive that link as synchronized on the receive side. By the same token, if you're sending transmit link number 1, you should be prepared to receive that same link number. It has to match the TX link number from the producer axis. So that's pretty straightforward. Now, because we're the receiver, this parameter 42 in menu 10 is saying, well, what am I going to do with that? Where am I going to store that parameter that's being sent? So here is you're going to flag the first parameter. If there's more than one message coming on the link, then you flag here the first parameter number in the block of contiguous parameters that are going to receive that message link. So if I'm sending 5 messages from 1801 in the transmitter, I'm going to need to receive 5 messages in the receiver. So this is the first parameter in the receiver, and then the other 4 parameters contiguously will be populated with the other 4 transmitted links. So that must match what the transmitter is, this must match the parameter count. If I'm sending 5, I have to receive 5. And I have to put those 5 here first. So destination parameter, and then the number of subsequent parameters that will also be included in that link. And then the source type. This depends on how the producer is sending the message. So if he's sending it as a direct message, then I'd choose direct. If I'm going to be part of a multicast group, then I'm going to receive it as a member of a multicast group. So I would match the multicast that the subscriber is sending, or the producer is sending. And then there's an option for local when I'm receiving from the factory fit module on a host drive. Right? So that's a possibility as well. And then finally, the timeout. This is a watchdog in milliseconds during which a message must be received. So let's go back and look at Connect quickly here. So here they are, timeout. Now what I'm going to describe next in the slides is the timeout action. This is more important than what you might think. What am I going to do as a receiver or as a subscriber in the event that the watchdog timer elapses without a message being received? How am I going to handle that? Well, the option is to trip. So if I don't get a message, the drive itself will trip, and it will have what's a slot error. So in my case with Digitax, it'll be sl.3.er, a slot 3 error. I can clear output. What that does is the values for all of the messages received on this link will be set to 0. Or I can simply hold the last. Retain the values received on this link from the last successful transmission. Excuse me. Of those, I would highly recommend trip. If there's something wrong and I'm relying on mission critical data, well, I want to know that that message has not been received or that packet is not being received. So I generally choose to trip the drive if the message, if the Watchdog times out. Now, if you're using an MCI module, we have events. The MCI module, if you went to my Machine Control Studio training, it has 4 event tasks. Well, that's what we're looking for here. If that trips, or if we get a Watchdog timeout on transmission, I can also initiate an event task. So that's not applicable to what we're doing today, but know that that's an option. And then finally, the event type is the task number for the MCI control module, and there's 4 of them. So if I were using an MCI module, I could flag an event task when it's tripped, and the code in that event task would then maybe clear all the digital outputs, put the machine in a safe state. But again, we're on a base drive, that's not an option. So that's the nuts and bolts of an easy mode link, but now let's put it into practice. One of the more common uses of this is to pass the position reference of one drive to another in order to synchronize the speed of the 2 motors. If you've ever done a master-follower type of application before, well, using traditional means, you would have a master encoder somewhere, and then you'd wire the encoder pulses out of that encoder in a daisy chain fashion to all of the followers who are going to be following that speed reference. Well, that method is fraught with disaster, potential for disaster. You end up losing pulses, gaining pulses, noise, cabling, all that sort of stuff. Using RTMoE, we can pass that signal at very high speed using our RTMoE protocol over Ethernet. So that's what I'm going to demonstrate today. And there are 2 options on how to do velocity synchronization in the follower. Okay? I can use menu 13, which is called the standard motion controller, and the follower, which is what I will do today. But I can also use gearing in the AMC. I can also use EGB mode with our advanced motion controller to do velocity synchronization in the follower axis. Today I'm going to use menu 13 just for simplicity. So here's my demonstration. I've got a producer axis and a subscriber. Now again, you don't start your drive commissioning by setting up easy mode links, clearly. You'd go through and commission the drive, motor, feedback, get everything running smoothly like you'd like it. Then we'll come and do this messaging. So after commissioning, I'm going to configure the transmit link in the producer. Then I'm going to switch over to the subscriber, and I'm going to configure menu 13, which is the standard motion controller here. Then I'm going to configure the receive link in menu 10 on the subscriber. So that's what I intend to demonstrate here. In terms of what I'm going to be transmitting for the producer here, I'm going to be sending menu 3 parameter 29, which is the axis position as measured by the motor encoder for this axis, which is attached to P1 on our high density 15 pin encoder connector here. So I'm going to send that position down to the subscriber. And this is an example of a mission critical link. So I'll configure the producer to become a gateway, and I'll also enable VLAN. So let's start with step one, which is the producer access transmit settings. So here are the values of the parameters that I'm going to be setting up in menu 10. So let me go and do that now. All right. Now this is the subscriber. We're coming to that later, so I'm going to close those. And we will focus on this guy. Parameter listings, menu 10. So this is my producer. So I'm going to say this link is going to be synchronized. That's a synchronous link now. And I will go back to my show. That's transmit link 1. Here's the source parameter, which is menu 3, parameter 29. Notice you can send data or parameters from modules also in other slots. But I'm going to just stick to slot 0, which is the base drive, menu 3, parameter 29. That's the only parameter on this link. And because I have only one drive in my network, well, I'm going to send that as a unicast message to my subscriber. And again, about the minimum practical message rate for base drive, factory fit modules, is 4 milliseconds. So that's how I'm going to configure my transmit link. So this is link number 1. So that becomes 03029. Enter. So that's what I'm sending. I'm going to send one parameter, unicast, to the IP address of the subscriber, which is right there, 192.168.1.30. And then the message rate, we're going to make that 4. Just like that. All right. Now that I've done that, we're going to reset slot 3 using the reset icon on the Connect dashboard. Well, I'm going to begin by resetting the protocol. 3.10.02 to on. Actually, I'm going to begin by saving parameters in the drive. Then I'm going to come up here to this reset, which resets the protocol. Now watch what happens. Goes off by itself. Then I'm going to finish right here with this reset. And it'll dip offline for a moment. It takes about, and this is important too, it takes 20 to 30 seconds for, once I reset that, to bring things back online again. So you can see here we're still active here. Right? And if I wait there long enough, it'll come back online. But let's move along. So there is my transmit message. And that's all I need to do in the producer. So the rest of this now will be the subscriber access. And I'm going to begin here by setting up the standard motion controller in the subscriber. So let's go look at that now. Well, come on now. There. Sometimes you have to do that. It should pick up on its own. But you can see we're back. I'm the Grandmaster. And away we go. So now let's go to the subscriber. Here. And we're going to begin with menu 13 here. All right, now let's look at those parameters. First thing I'm going to adjust is where's the reference for this is where is the gearing reference going to come from? Synchronization reference. And by choosing local, what that means is that rather than having the reference come from an encoder on a module or an encoder tied into the high density 15-pin port on the drive, the reference is coming in locally over the link we're going to be sending. So I'll begin by changing 1304 here from P1 drive to local, like that. So just like any other motion controller, that's the command signal. Where's the feedback? Well, that is coming from the motor. So I'd leave that at P1 drive. So it's command, feedback. Right, there is the gear ratio. And I'll leave it 1:1. I could adjust the gain term if I wanted to stiffen the loop. This is what has the effect of enabling or disabling the motion controller. Whenever I change this value in parameter 10 to anything other than disabled, now it's going to, the motor speed, or the motor speed in this case, is coming from whatever I'm sending. So once this is enabled, I'm not going to be able to run from an analog speed reference or a preset speed reference or anything else. It's going to come from the link that's being sent by the producer. So there's different modes for this, and I'm not going to go into the detail on that right now. If you look at the help file and connect, it'll explain what this is. But I'm going to choose non-rigid speed feed forward as the motion control mode. So let me go there. Oop. So here's my options. I'm going to choose non-rigid speed feed forward. I have an absolute encoder, so I'm going to enable absolute mode. Right there. Now this is not a maximum speed. All right, that's confusing. This is the maximum amount of speed command that the drive will use to correct for position error. All right, so this is like, you know, if it's lagging, it's going to add up to 150 RPM on top of the command to try to reduce following error. So that's not a speed limit, even though it says it is. Okay, so the rest of this stuff I'm all going to leave at default. The last thing I'm going to do is come to parameter 24. I have a single turn encoder on these demos, so I'm going to turn this on to enable the revolutions part of my position word that's coming over. So I'm going to turn on 1324. Like so. Now the real reason that I set the transmit link to 4 milliseconds is right there. That's the sample rate. There's no point in sending the reference faster than the drive can handle it in the first place. So 4 milliseconds is what I'm going to leave that at. So that's menu 13. All right. Now let's set up the receive link. But before we do that, I want to make sure that the settings in menu 2 are as shown here. In other words, I have to have the VLAN enabled because it's enabled on my transmit or my producer, and I have to have VLAN ID 1. So let's go look at that quickly. right? Now, gateway mode is switch. That's what I want. VLANs on, VLAN ID is 1. So that's all good to go. Now here are the receive settings for receive profile 1, right? So there again, I'm sending a synchronous link, so I need to be prepared to receive that link. Right there, as synchronous. I'm sending link number 1, so I have to receive link number 1. Now the destination parameter, I'm sending the reference to menu 13, parameter 21. So let's look at that. Oop, not there. Here. 1321, standard motion local reference position. So I'm sending the position of the producer right here for the subscriber to follow. And again, that's what local means up here. I'm only producing one message, so I'm going to receive one, and it's coming directly because it's being sent as a unicast message from the producer. So let's go do that. Menu 10. All right, so I'm going to go down and start with parameter 40 right there. Sounds like we have incoming. So that's a synchronous. Receive link 1. Okay, menu 13, parameter 21. Parameter count is 1. It's coming to me directly. So that's all I need to do. Now I'm leaving all the trips and all that. I want it to trip, which is the default, and that's the Watchdog, so I'll just leave that as is. So that's my receive link. Now what I'm going to do is save parameters in the drive, reset the protocol, reset slot 3. So I'll come in here, save parameters in the drive, come up here to reset the link. Okay. Then finally, I'll come here and reset it there too. Okay. Oop. Now watch this. Synchronized, no. Watch this fall now. And again, it takes 20 seconds, 30 seconds for this to happen. See, it's decreasing. There we go. We're getting there. Not quite yet. Oh, now we're getting down there. Okay. I expect this is going to say synchronized yes pretty soon. There it is. So now we should be good to go. So to make sure we are, I'm going to look at menu 11, parameter 8, module synchronized. That's what you were just looking at a minute ago. It should say yes, but we'll check. Yes, module is synchronized. Now back in menu 10, there are 2 more parameters. Parameter 5 will tell you if your messaging network configuration is valid. Menu 6 will confirm that the link is operational. So you always want to check those 2. So I'll come in here now. Yeah, on. And then finally, I'm going to check the status of the link, which is parameter 49, receive link status. And what you want to see is OK sync. So there it is. And there we have it, OK sync. So at this point, I should be able to run it. And there we go. You can't see it, but trust me, maybe you can hear it. So I'm following along quite nicely. If I go look now here, you see this is in counts over 65,535. So even with the default gains, that's following along very closely. And the last thing I will do, or I'll show you, is this. If you look at it, use our CT scope software, you can graph out how well the velocity following is performing. So the yellow trace is speed reference, that's coming from the master. Red is speed feedback, and green down at the bottom is the speed error. So you see I get a pulse of error when I'm accelerating, and I'd see another one if I were to stop. And that's because I have an acceleration rate of 200 milliseconds in my subscriber. So if you want it to follow without any hesitation, whatever the master's doing, you would go in to menu 2. Let's see. I would come in here, speed ramps, and I would disable the ramps. Otherwise, whatever you have here is going to come into play when it comes to following the master. So, that's all I have for you today. Does anybody have any questions? I'll stop this.
Oh, that was pretty concise.
Okay. Good. Anybody else? All right. Well, thank you again for attending.